Hello, welcome to Let's Do It Live. Again, my name is Preston. I'm happy to be here, though sad that I was not able to make it to Rome and actually meet all of you. Online, you can find me at Novox Populi pretty much everywhere. I work for CrowdStrike, which is a lot of fun. All my coworkers are a very caring bunch, the benefits are great, and everyone understands that mental health is super important. Like, I had some coworkers recently and my manager tell me to take some time off, and I really appreciate that. So I work remotely here. Let me zoom in a bit. Yeah, I live here. I used to live here. Here's pretty cool. For reference, New York City is way over here. But yeah, anyway, CrowdStrike is remote first, so if you want to come work with me, work with Ember, and or solve hard problems, visit this URL. QR code in the corner for the fast people. Getting right into things, gotta cover some nomenclature so that we're all on the same page, as words can be kind of funny. REPL. This is what Wikipedia says the definition is. A read-eval print loop is a simple interactive computer programming environment that takes single user inputs, executes them, and returns the result to the user. Now, usage of the word simple may be up for debate. At the highest level, sure. But like most things, it gets really complicated when you have to deal with async, errors, UI, and just a bunch of stuff. And I personally consider the whole experience to be part of what a REPL is. So in JavaScript, you may interpret a REPL as this code block here. Now that's kind of goofy to read. And because we like fancy and shiny things, this is what it could look like using the pipeline operator, which is stage 2 at the moment. And here are some examples that are a little more complex than the previous slide. You may already be familiar with these. When I was looking up the definition of REPL so that I could try to sound smart and impress all of you, I was surprised that shells, like the terminal that I use every day, is considered a REPL. Now, I hadn't ever considered that because, I don't know, I just use it all the time and kind of took it for granted, and I didn't really think of it that way. So playground is maybe a less scary way of saying REPL, and it's mostly a synonym. But to me, playgrounds may include higher level interactivity than a REPL would. Maybe, for example, the XState visualizer. Because you still have your editor on the right and your preview on the left, but you can actually click around and interact with it. But maybe it's the same, there's not a difference. That's why they're kind of synonyms. Why do REPLs matter? Why work on them for Ember? Maybe why add one to your style guide, or why add one to your open source library? Maybe you've never considered these questions before. For design systems, component libraries, add-ons, or whole frameworks even, anything with reusable pieces, a REPL can provide consumers of your project the ability to play around with components, modifiers, CSS classes, or whatever your public API is, demonstrate capabilities of what your library is providing, provide a way for users of your library to provide issue reproductions so that debugging is a bit easier, or you can share ideas, concepts, and examples with your users when questions are asked. A REPL example made in response to a question is far better than static documentation, which may be overlooked, misunderstood, or both. So let's see a demo. But first, I'd like to give a special thanks to a couple projects. So Ember Template Imports was mentioned earlier in Emberfest. It provided inspiration as well as syntax for the demo that I'm about to show you. The GlimmerX repo has some experimentation going on that Ember Template Imports is also doing. But GlimmerX is a monorepo, and the project in there that I specifically want to call out is the GlimmerX Playground. This project taught me a lot about editing on the web, primarily dealing with Monaco, the web version of VS Code. From both projects, I found Babel incantations that would allow for this. Back to the demo. So just giving a brief tour of the other demos that I'll show later. This is the homepage of a little side project I've been working on. On the left is an editor, and on the right is a rendered preview. In this editor, there is a mix of Markdown, HTML, and Ember templates. And at the moment, this is using Tailwind, so this block here won't show up on small screens. So if I open the DevTools, that little select demos block is now missing. If I close the DevTools, it comes back. All of Tailwind's in here, and I can add entries to this array, just iterating over the each right in line with the Markdown. And it behaves just like a normal application template. For each entry, and a list item containing a link is rendered. Now, whenever I make a mistake, there's this little error message in the bottom right. And kind of a caveat of working with Markdown, is that every empty line is an escape back to Markdown from Ember, which is why this error shows up. We'll ignore that for now. So even as I edit normal HTML things, I get helpful errors from the template compiler so that I know what I need when I need to go fix something. Yep, error resolved. All right, so looking at the top here, there are some buttons. This Ember tab has a preview so you can see what the output of the Markdown transform is. That can be helpful for debugging. And then these buttons are for minimizing and expanding the editor, like if you need to take screenshots. I want to introduce something that I maybe biasedly think has some potential, but maybe more of as a concept rather than this specific execution. This is kind of how I imagine this sort of thing being used for live documentation. For example, this external link component, which renders with some linkish styling, underline and icon and all that. This is using the GJS format introduced in Ember template imports. These template tags right after the import are supported via Babel transform. So it's the same Babel transform used by Ember template imports, so it's like the exact same. And I think the future of Ember will greatly be benefited by having some sort of all-in-one syntax, because it enables not only an entire component to be defined in one code block, but it allows easier understanding of where components come from via imports, which folks are familiar with from ES modules. So you no longer need to search entire projects or search node modules trying to find what you're looking for. Something else that I think would be useful for style guides is to have a shadow DOM wrapper component. So in this example, I have two unordered lists, one outside the shadow DOM, which has correct list styling, and one inside the shadow DOM, which doesn't have any styling applied, which is correct for Tailwind users. So here is maybe a real-world example of how you'd want to use all of this together. And thanks to the shadow DOM, this header component renders the exact same as the top of the app. And I think that's pretty cool. Now, I don't know if this is an issue outside of Tailwind, but Tailwind's pretty popular, so the shadow DOM thing is pretty neat. And here's another example using a menu. This uses headless UI, which was mentioned earlier. So opening the editor now, I'm just going to scroll to the links. And then you still get live updating as you would expect. You still get helpful errors and guidance, so you don't accidentally create invalid code. And this is significantly faster than changing code and waiting for your whole app to refresh. Like, even if you use hot module reloading, like just having it update right here is much faster than reloading a module. So yeah, and then to see what something looks like without the shadow DOM, I'll remove this shadowed wrapper, and you'll see just how important that is. Oh, yeah, so shadow DOM's really good. I think it's essential for a design system. So going to take a quick load performance detour. This is all the code bundled and shipped whenever a deploy happens of this app. So this app ships with two editors, and I'm still experimenting with them both, and I'll be adding better glim down support over time, maybe a really long time since this is a side project. But something I like to keep in mind with these editors, so Monaco, again, the core editor used by VS Code and what all online or in-browser VS Code clones use, is huge. It's a little over 9 megabytes here, uncompressed. Now this, I do have it configured a certain way, but it's not going to get too much smaller than that. And that's why I don't load the editor until I'm certain what sort of device will be used for editing. Now, Monaco has a lot of features, so with the right plugin work, it can provide an absolutely stellar editing experience. Now, however, there's another editor, CodeMirror, version 6, which is a rewrite of maybe the CodeMirror you've used in the past. It's super cool architecturally, and there's also something I've been thinking about, like maybe ditching Monaco in favor of CodeMirror. Like CodeMirror is favoring accessibility, works on mobile. It's got a lot of good stuff going for it. And I don't know if you've spotted it yet in this slide, but CodeMirror is the little blue rectangle on the right here. It's 550 kilobytes, about 6% the size of Monaco. Most importantly, it's all super modular, so it's fairly easy to include what you need, but the ecosystem around it is much smaller and younger, so trade-offs. Anywho, this is the code that is rendered on first load. The dark blue rectangle is my app code. The biggest rectangle, chunk F75, are my non-async imported node modules, including the template compiler. I don't know if you can spot the template compiler. It's somewhere in there. I identified these bits, and that's not all of it. And I think Embroider and Webpack are doing some neat things to the build, because if you pop open the EmberSource npm package, you see this, a 261 kilobyte collection of AMD modules. And I can only assume all of those modules get shuffled around during the build. But I'm by me doing nothing and letting Ember gradually remove the old stuff over time. And at the time of running this page speed insights benchmark, the app was using Ember 4.1 Alpha 2. So I think it's kind of important to talk about this sort of stuff because it can get overlooked in big projects and or big teams, especially with deadlines and the ever-increasing amount of work to do. You know how it is, just stuff keeps piling up. It can be very tedious to rewrite stuff to have asynchronous module loading expectations after the fact. Anyway, back to REPLs. How does it all work? And how can you and your team make a REPL? Let's dive in. Now, before we get into the details, this is something silly I wanted to show. Also available in this example REPL is a demo of building a REPL in the REPL. So this is the absolute bare minimum you can get away with for building a REPL in Ember. The main difference here is that for simplicity, there's a render button on the right. So instead of re-rendering as typing occurs, after clicking render here, the code from the text area is rendered below. And this is the classic click to increase a count demo. I'll just click the button a few times. So like the outer REPL, I can edit this text. Just change the numbers. And then click re-render. And it acts as you would expect. So the code is still using the GJS format with the template custom syntax within the class. This could be done without GJS, but then it's quite more verbose, which we'll get to later. All right, so what's this look like? This starting code we have here is what was rendered within the text area. And then below that is the example REPL component. And the whole thing fit inside one component, but what we're going to focus on for right now is the template, which is just a text area and a button in a form, and then some conditional rendering of this dot component down here. So this is the main code of relevance for how REPL works. The bulk of what happens is in this compile.js function. But what's that do? Let's dive into the rabbit hole and reveal that there is no such thing as magic. So here there's just some re-exports declaring public API. We need to go deeper. There are only two areas of interest in this function. This compile.gjs invocation, as well as eval snippet. When you look at this chunk of code, the first thing you see is Babel. And you might be thinking to yourself, maybe terrified, oh no, I don't want to have to understand Babel or how to configure it. Well, you're in luck. Because while it's not magic, ain't nobody got time for that. So instead, at a high level, this is what's happening. Given, we have this GJS template, but as a string, but then we have no syntax highlighting, and that's nice, so let's pretend the original code is a string. The first thing that happens is that these template markers are identified and extracted, and become this, sort of. If you wanted to do single file templates today, or have multiple components in one file, this is how you would do it. For components in a normal app and add-on, this is what happens during the build process. Your HBS files are inlined with the component class file, and set component template is used. Now, to use strict mode, though, is a bit more verbose, and this is why the GJS format is such a nice shorthand. But what about this? This HBS function also has a hook into Babel. Though this is sort of a lie, the HBS function from Embercli HTML bars only supports the loose mode compiling, which means you don't need to import the on modifier. So what's happening in this app and what needs to happen in single file components is strict mode compilation. So that means that when the template is compiled, a list of references is collected, and if these references don't exist, rendering will fail. Now, when debugging your own code, you may have seen this, like maybe if you have source maps turned off. So your actual code is commented out and replaced by some JSON. Now, these are the pieces that are different from normal app template compilation. The scope is a list of external references that the template doesn't inherently know about in order of appearance, and is strict mode tells the compiler to not use the global resolver, which requires everything to be imported. Note the create template factory at the top. So here's the full thing. Got your component class, set component template, create template factory, and then some JSON. And yeah, no more template. Okay, so now that we have our compiled code, let's move on to evaluation. And there's some trickery going on here. There's an eval here, because we have JavaScript we need to run. Now, according to MDN, we should never use eval. But in this case, this is exactly what we need. And using the recommended function approach, later demonstrated on this MDN page, would not work. So never use eval. I say only a Sith deals in absolutes. So this is a hack that relies on both the scope using nature of eval and on Ember's old or current build system, depending on your frame of reference, but it uses AMD/require.js for handling modules. And this allows us to dynamically hijack the require.js require method and provide our own modules. So this is what's happened here. I've set up some default modules for all of the Ember stuff. So when writing style guide stuff, you maybe don't need to worry about whether or not, you try to import from Ember destroyable and it doesn't exist. It's provided this way. And you may be thinking, why provide that list if you know that all of these modules are available when you write code in your app? Window.require is private API, and we can't reliably rely on it. So, and what I mean by that is, like, it could go away in the future. So if you use it in production, you might want to take a look at some less dynamic options, such as those provided by Embroider macros. And for much of Ember, these modules were all fake and replaced during the build via Babel transform. But as of 3.27, Ember Source ships real ESM, so that's very exciting. So now back to compile.js. We can now follow the return and back to the actual code in the app. And if we have a component returned, which we may not if there was an error, we can assign the component and then render the new component in the template just at the bottom part there. Now we want to be error and fault tolerant best we can, so as you're building your own REPL, you may want to use this way of handling errors. Only setting the new component value if there has been no errors compiling the latest input. Also remembering to clear the first thing at the top. This means that invalid content won't replace the last valid content, which is less jarring for users. Alright, so moving on to things that make REPLs better and less developer-y. We need to handle compile errors in a delightful way. We can achieve this by either running Ember template lint in the browser or running like Glimmer syntax over a template. The important thing is no matter how the input is invalid, we need to provide contextual errors when possible, and really helping out the user whenever we can. This is using an existing error provided by the compiler, but rendering that error aligned with the correct context so that the user doesn't need to go look for that line column. Now, in a normal template that's only 2 lines or 3 lines long, you maybe won't have a hard time finding that, but this is more of an issue with bigger templates or in a glimmed down REPL like this. There are multiple templates, so you might not even know which one to look at. Another thing is error boundaries, and these are a concept I know from React, where you could have any part of your render tree throw any sort of error, and the error boundary would capture that error so that the entire app didn't crash and then render an alternate UI. Now, for a REPL using Ember, this will absolutely be a requirement before we can have an interactive tutorial like what Svelte has. If you haven't checked it out, it's great. Now, certain classes of errors encountered during the rendering of in-progress components in Ember will cause the entire app to crash. For example, when helpers and modifiers have invalid references. Hi there. Neither hi nor there exist in scope. That's a shame. Didn't play. This is what shows up. The page refreshes, the whole UI redirects to that markdown preview page so that you don't get into an infinite refresh loop. This little message shows up in the bottom right corner. I've added this top bit here. The bottom is the error you'd receive in the browser console, but that's not super helpful. And I also want to take this time to point out that the Ember core teams have done some great work improving our error messages in general, but I also wanted to encourage everyone, regardless of experience, to either open issues or report any discomfort whatsoever with errors. And I think together we can make compiling delightful. Containerization. It's fairly new. StackBlitz has been making waves on Twitter recently. They've made an entire web development environment in the browser thanks to web containers. And unfortunately, they're only supported in Chrome at the moment, which is a tad disappointing. And kind of coming back to running arbitrary code in the browser, you might be worried about security. And it doesn't matter if you're using eval or dynamic import maps or web containers, because the code that runs in the same context as the author. You only need to worry about security if you're persisting changes to code and serving them to different users, because that's when you could get nefarious actors trying to steal information from people. So in that situation, Ember has your back in some ways. So like during render, script tags and anything that could be used maliciously are stripped from input. But for other kinds of attacks, you'll need to ensure you have a change review process set up, such as you would with Git and pull requests. By the way, if you're wanting to try out the latest Ember without having to make any files on your machine, you can visit any of these Stack Blitz URLs in Chrome. They are always up to date. They don't need update PRs or anything, so you can rely on them. The only caveat is that if Stack Blitz accidentally breaks something, which they're in kind of like a pre-beta phase right now, so user beware. So editor support. Today I'm using Monaco and CodeMirror with minimal syntax highlighting additions. Now again, I'm still figuring this out. CodeMirror seems like the better approach, even if it needs more tweaking. Their goals are a bit more noble than Microsoft and Monaco. But regardless of editor choice, what we'd want to add is contextual syntax errors, like mentioned earlier, some code lens-esque features that clearly tell you what mode you are in within your document, essentially for hybrid documents like Glimdown, especially for folks new to the language. We need to give clear indication as to when the cursor is in Markdown mode and when it is in Glimmer or Ember mode. We also want seamless integration with Git within your browser. And that might seem like a lot, but it could be handy if you want designers and content writers to use your tool to write docs as close to the code as possible without having to actually program. So maybe you deploy your style guide somewhere as well as the editor, and you can just edit right there. Thank you.